Hello everyone. So today we are going to continue with the integration exercise 7.5 and this is part 2 video. Here we will discuss the question number 11 to question number 23. Right? As you know, this is the class 12 topic and we are targeting the board 25, 26. Right? So it is NCRT new NCRT book solutions. Right? So the question number 11 here we have given integrate 5x into dx by x plus 1 into x square minus 4. So first we have to factorize this x square minus 4 here. So I will write let I is equal to integrate this 5x into dx is equal to this x plus 1 as it is, but this x square minus 4 we can write it as x minus 2 into x plus 2. Because here you can see it is a square minus b square, right? So just we are splitting it, applying the identities. Right now here we can apply the partial fraction. So for that we will copy this again, means 5x divided by x plus 1 into x minus 2 into x plus 2. We will write like this. After that we are going to take each factor a divided by x plus 1 plus b divided by x plus 2 and then c divided by x minus 2. Right now we have to next step we have to take the LCM. So we will take the LCM here and denominator also we will cancel same time. So 5x will be equal to 5x is equal to a will be multiplied with x plus 2 or we can say x square minus 4 or we can multiply x plus 2 x minus 2, right? Now plus b we will multiply with x plus 1 as well as x minus 2, right? Now plus c will be multiplied with x plus 1 and then x plus 2, right? This is the equation. Now we have to find the values of a, b, and c. So for that we are going to substitute the x value is minus 1 here since it is x plus 2. So that a and 2 out of the three constant, 2 should become 0 and we'll get the third constant values. So here we are putting x is equal to minus 2. So if you are substituting x is equal to minus 2 in the above equation, it will become what? 5 into 2. Here we can write 5 into 2, that means it is minus 10 is equal to minus 10. Here you see the a will become equal to 0 because x is minus 2. So minus 2 plus 2 it is 0. Overall this term 0 and c also will become 0 in similar way. So only we have b terms. So b is equal to what? So b is equal to x, that means minus 2 plus 1, that means it is minus 1. Right, and now x minus 2, that means x is minus 2, so minus 2 and minus 2 it will become minus 4. Right, so from here we can say we have now minus 10 is equal to 4b. This is equal to 4b, or from here we can say just b equal to what? B equal to we have just 1 second here, not 4. So B we can cancel also. This 10 and 4 means in 2 10 and this is 5 10. So B equal to minus 5 by 2. From here we can say B will be equal to minus 5 by 2. So we got the one constant values. Now we have to find out the other two also. So for that, let's substitute the another values of the x. So x is equal to, let us suppose we are putting 2. So in that case, again a will become 0 and this time b will become 0. Only remaining will be c. So here 5 into 2, it will become 10. We are putting in the above equation only. So this now here 5 into 10, 5 into 2, 10, and this is a0. Just I am writing c part. So c into 2 plus 1, 3. and 2 plus 2, it is 4. That means from here we can say C is nothing but, here we can cancel the 10 and 4 also, or it is 10 by 12. That means we can say 5 by 6. 10 by 12, I am writing in the simplest form. So this is our C. Now we need to find out the another one more constant. For that we are going to substitute, put x is equal to minus 1. Put x is equal to minus 1 in the above equation. So this time b will become 0 as well as c will become 0. So only remaining terms will be a. That means it is minus 5, and minus 5 is equal to a, and it is x is equal to minus 1. So 2 minus 1, it is 1. And minus 1 minus 2, it is minus 3. Minus sign will get cancelled from both sides, LHS and RHS. So we have just now a is equal to, we have 5 by 3. A is equal to 5 by 3. Right, now we have all the three constant values. So we can take the integration of this equation now. Means this is, let us suppose, our first equation. So we are going to take the integration sign on both sides. So if you are taking integration, the LHS is nothing but integration of the LHS is equal to I only, right? And RHS is integration of A upon x plus 1. A is what? So A is 5 by 3. So here we will write 5 by 3 divided by x plus 1. Here dx. Right, now plus b is what? B is, here I will write b is equal to minus 5 by 2. So this will be minus 5 by 2 as it is. And this is divided by x plus 2. X plus 2 here into dx. And last term is what? Plus C. C is what? So C is 5 by 6. So here you will write 5 upon 6, and this is divided by x minus 2. X minus 2 here dx. So now we can integrate it very easily. Alright, we can here take the 5 by 3 constant outside and write the answer for this first integration is log mod x plus 1. Alright, here we will take this minus 5 by 2 outside, and this will become log mod x plus 2. Right, here 5 by 6 is outside, and then it will become log mod x minus 2, and here plus c. Right, so we will leave our answer here. So this is the final answer of the question number 11. Now we'll move to the question number 12. So in the question number 12, what we have given? We have given a cubic equation by quadratic equation. That means first we have to convert it into proper fraction. How we can do that? Or here we can apply the, no, we cannot apply any identities directly. We have to first divide this numerator with the denominator part. So here we are going to divide this x cube plus x plus 1 with x square minus 1. X square minus 1. So it will become, in how many times we have to divide? So here quotient will be x. So that x into x square will become x cube, and this will become minus x. So now we have to subtract it, minus, and this will become plus. So the first term cancel, it will become 2x and plus 1. That means now we can write our integration as, I am considering the given quotient as I. So I is equal to, we can write integration of the quotient, that is, here it is x plus remainder is 2x plus 1, and this is divided by divisor, that means x square minus 1, and here bracket close, and then dx. Right, now we have to take the integration separately for both the terms, and actually this term also, the second term, we can further split it into, divide this both 2x and 1 by the denominator. Means here we are going to write it as I is equal to integration of x separately, dx I am taking with that, and plus this 2x we can divide by, this 2x will be divided by x square minus 1 and here dx, and then plus integration of 1 by x square minus 1 and here also we have dx. Right now we can apply the integration formula, but before that we have to here apply the substitutions method. Here we have to apply the substitutions method. That means we have to assume this x square minus 1 is equal to t. That means the differentiation will be 2x into dx is equal to dt. That means here integrations will become what? It will become t divided by, not t divided by, it is dt. It is dt and divided by here. Let me write it properly. This is dt here, it will become dt and this is divided by t, right? That means here for this part answer will be log of what? Log of t. And since we know that t means what, so t means it is log of x square minus 1. So for this part this is the answer. That means our final answer will be, our final answer here we are going to write I is equal to the answer for the first part, it is x square by 2, right? It is x square by 2. From the second part, we got log mod x square minus 1. And from this is actually direct identity. Here it is x square 1 upon x square minus a square. So for this we have direct formula 1 upon 2a. A is 1, so it is 2a and log divided by, sorry, log mod x plus minus a, that means x minus 1 divided by x plus 1 and here plus c. So this is the final answer. We can leave our answer here. So question number 12 done. Now we will move to the next question, that is question number 13. So in the question number 13, we can directly apply the partial fractions because here we can see this is only the factor of two expressions we have given. We cannot factorize it further. So here we can write this 2 divided by 2 divided by 1 minus x into 1 plus x square. This can be written as a divided by 1 minus x plus, since 1 plus x square is non-factorizable, so it will become bx plus c and this is divided by 1 plus x square. Right now we are going to take the LCM on both sides, so it will become, and same time I will cancel the denominator. I am writing only numerator part, so 2 will be equal to a into 1 plus x square and here bx plus c will be multiplied with 1 minus x. All right. So we have to simplify this LHS part. Means this 2 will be equal to here a into x square. I'm writing first the second term. That means here a plus the x square will come. So I have written ax square and then I'm writing a. Just we have to multiply a with both the terms. And here now we are going to multiply first with the 1. So it will become b into x plus c. And now we are multiplying with the x. So it will become minus b x square and this is minus cx, right? We are going to write the same power. We are going to take the common power of the variable in a bracket, right? Together, same power we are going to take common. That means if you see here, a is also multiplied with x square, b also is multiplied with x square. So we are going to take the x square common from this. That means it will become a and minus b common is x square. Now we will see what are the x coefficient. So here b x and here it is minus c. So here we will write now plus b minus c into x. Now constant term is a plus c. So at last we will write here the constant term. Constant term is a plus c. And left side we have 2. So now we can equate the LHS and RHS coefficient. So if you see here, the coefficient of x square on the LHS is nothing. There is no x square term means 0. So we can write a minus b from here is equal to 0. Right? So this is our first equation. Or from here we can say a is equal to b. Right? Since a minus b is equal to 0, so b we can take in RHS side. Similarly, from B minus C, if you see here the coefficient of the B minus C, then this is also 0 because there is no x term in the LHS side. Means this is equal to 0. So from here, what we can say? B is equal to C. Now here we are getting A equal to B and B equal to C. What does it mean? So from here we can say no, all A, B, C are equal only. Means A is equal to B is equal to C. Right? Now we have one more equation constant term. This constant is equal to what? So this is equal to 2. Means from here we can say A because constant is given in the LHS side. So A plus C is equal to 2. Now we have to replace A and C in the both in the same term, or we can say C also is equal to A. So here I am writing A, and I am going to replace C with the A because we know that A, B, and C all are equal. So it is also A, and this is equal to 2. That means finally what we can say this 2A is equal to 2. 2A is equal to 2. That means A is equal to what? That means from here we can say A is equal to 1. Now we have A equal to 1. That means all ABC are equal to 1. Means A equal to B equal to C, all are equal to 1. So now we can write our answer here. So for answer actually we have to write the first step here. Means next step will be we can take the integration here for this equation on both sides. That means if you are taking integration on LHS side, it will become I only, right, equal to the given questions only because LHS here is nothing but questions only we have written. So I is equal to integration of a upon 1 plus x. So what is a? A is equal to 1. So it is 1 plus, sorry, it is 1 minus x. It is 1 minus x. So here we will write 1 minus x into dx. Now for the second part. Plus b is also 1. So here b into x plus c. That means it will be x only and plus c is 1. So x plus 1 divided by 1 plus x square. 1 plus x square into what? Dx. Now how we can solve this? The first part is simple, but second we have to just split it. We have to think how we can integrate the second part. It is x plus 1 divided by 1 plus x square. So here we are going to rewrite this I, means we are going to split this. We are going to divide this x by 1 plus x square and 1 also by 1 plus x square. Separately, we are going to take the denominator for both the values x and 1. So this will become, here I will write it as 1 upon 1 minus x into dx plus x divided by 1 plus x square into dx plus here 1 divided by 1 plus x square. Actually, this is the direct formula base, right? But here in this second term, we have to apply these substitutions. Here we have to apply substitutions. Means what? We have to assume let this 1 plus x square is equal to, let us suppose if we are taking t. So what is the differentiation of this? That means it will give 2x into dx is equal to dt. That means from here, what is the value of x time of the dx? So it will become 1 by 2 time of the dt. Means the answer for this part will be equal to what? Here it will become integration 1 by 2 constant we can write outside, and this will be written as dt divided by t, right? That means here it will become 1 by t, 1 by 2 log mod t, or here I will write as it is first. We can replace t with x terms. Means what is the relation between t and x? We have assumed t is equal to 1 plus x square. So this is this. Now final answer we can write here. I will be equal to what? So I equal to, we can say finally, here I am writing the I. So first term integration will be, since here minus x is there, that means coefficient of the x is minus. So we have to be careful when we are writing the log, because here we will write log mod 1 minus x, but the, because of this minus 1 will come, because coefficient is 1 minus 1 right now, plus here we are getting the answer for the second term. Already we have simplified, it is log mod 1 plus x square. All right, and for the last term it is so directly formula based, and the formula for this is what? Tan inverse of x by a, that means a is 1 for this, and here at last we can write plus c. This minus 1 we can take to the, as a coefficient here, means we can write it as minus log of 1 minus x plus 1 by 2 log, here 1 plus x square, and plus tan inverse x plus c. We can apply the property of the log. This minus will go to the power of these values, that is 1 minus x, and minus x will become the reciprocal. Means one more step, if you want, we can write our answer, or otherwise we can leave our answer there also. So if we are applying the concept of the log property, then it will become 1 upon 1 minus x. 1 upon 1 minus x plus 1 by 2, and this is log of 1 plus x square plus tan inverse x plus c. You can see the answer here if it is not visible. Okay, so this is the answer, final answer of the question number 13. Right. So now I will move to the next question. What is the next question here? This is 13, so next is 14. In the 14 questions, we have given 3x minus 1, and this is divided by x plus 2 whole square. So what we can do, since it is x plus 2 whole square, means we can apply the partial fraction here directly. We don't have any confusion with that. Means we can write this, let I, given question is I, so I is equal to, or we don't need to write first I before that, actually we will simplify this. Means I am going to apply the partial fraction directly on the integrand. Means here our integrand is 3x minus 1, and this is divided by x plus 2 whole square. So it will become a divided by x plus 2 plus b divided by x plus 2 whole square. Alright. Now we have to take the LCM on both sides. So it will become 3x minus 1, and denominator we are cancelling same time only. So here it will become a into x plus 2 whole square plus b into x plus 2. So this is 3x minus 1, and this is equal to a into a plus b whole square, means it is a square plus 2ab, that means 4x plus b square 4, and here we are getting plus bx plus 2b. All right, now what we have to do, we are going to write the same power to we will take the, or before that also we are going to simplify this first bracket. So it will become a into x square plus 4a into x plus 4a. All right. Now this is as it is, second term bx plus 2b as it is. Now we can make the grouping of the same term, same type of the terms. Means here x square, we can see how many x square term is there? Only one. Means here we will write this only one x square term as, we will write it as a x square. Right? If how many x terms are there? So x here bx and 4ax. That means here we will take the 4a plus b together and take the x common. And the constant term is 4a plus 2b. 4a plus 4a plus 2b. And this is equal to 3x minus 1. Right now we can equate the coefficient of the x square first. So if you see here, the coefficient of the x square in the RHS part is, it is a, but in the LHS there is no coefficient of x. So here we can say a is equal to, there is no x square term, so a is equal to 0. Right? So finally, directly we got a value. Now we have to equate the coefficient of x. So coefficient of x, we can see in the RHS we have this 4a plus b, and in the LHS this is equal to 3. So since a equal to 0, that means from here b we will get equal to 3. So b we are getting equal to 3. Right? Now we know the values of a and b. So directly we can take the integrations of this first equation. We are giving the name of this equation as first. So I will become what? From here, if you are taking the integration on both sides, so LHS is called as the I is equal to a divided by 0, means this first term is going to become complete 0 only. X plus 2 into dx means it doesn't matter, just it is going to become 0, means b part is what? So it is 3 divided by x plus 2 whole square, and into what? So into dx. All right. Now we have to apply the integrations formula here, means our I finally will become I is equal to 0 and I to values. 3 is a constant. We can take 3 constant inside and we can write it as x plus 2 and minus 2 into dx. Then we apply the formula of the integration, so it will become 3, and here it is x plus 2 power minus 1, and this is divided by also minus 1. Right? Means finally we can say this is equal to minus 3 divided by x plus 2. I is equal to minus 3 divided by x plus 2. This is the final answer. All right. Now we'll move to the next question, that is question number 7. So in the question number, this is slide 7, question number 15. So in the question number 15, I think there is a mistake in this questions. We need to correct it. This should be the minus sign, not plus. So this is minus. Then only we can factorize it further. So here I equal to, we need to factorize first. This 15 question number, I am writing this is equal to I, and I is equal to what? So I is equal to, we can factorize, we can apply the identity a minus b. So it will become x square minus 1 into x square plus 1 into dx. Right now, further we are going to apply the identity on this x square minus 1 terms. This x square minus 1 terms, so this will become integrations of 1 upon this will become x minus 1 into x plus 1, and this is x square plus 1 dx. Alright, now we are going to apply the partial fraction on this term. Means this is our I, here we can apply the partial fraction, means it will become, here I am taking the integrate, it is x minus 1 and then x plus 1 and then x square plus 1. Right, so this can be written as a divided by x minus 1 plus b divided by x plus 1, and then this is non-factorizable, so we have to take the two term, that is cx plus d divided by x square plus 1. So now take the LCM. If we are taking LCM, here it will become 1 is equal to what? So 1 is equal to a into x plus 1 into x square plus 1 plus b into x minus 1 x square plus 1, and then plus here c x plus d here, and this will be multiplied with x minus 1 into x plus 1. This is our equation. Now we have to find the values of a, b, c from this equation. How we can do that? So for that, let's take the different values of the x. Oh, here since x plus 1 is there, so if you are taking minus 1, so the a complete a part will become 0. Similarly, for minus 1, c also will become, c and d also will become 0. So only we will have b, means 1 will be equal to what? So 1 will be equal to a b into minus 1 into minus 1. It is, sorry, minus 1 minus 1. So it is minus 2. And minus 1 square plus 1 plus 1. It is 2. That means from here we are getting b is equal to minus 1 upon 4. Minus 1 upon 4. Now we have to take the another values. Let us suppose this time we are taking x is equal to plus 1. That means put x is equal to plus 1. Put x is equal to plus 1 in above equation. So when we are putting plus 1, that means b terms will become 0 as well as c and d will become 0. Means only we will have remaining which term? So a, means from here we can say 1 is equal to, that means a into 2 and then into 2. That means from here we can say a is equal to 1 by 4. It is equal to 1 by 4. Now next what we can substitute here, now we can substitute 0 because we had two factor only, x plus 1 and x minus 1. So we already substituted. Now x is equal to 0 if we are substituting in the equation. That equation, then it will become 1, and 1 is equal to what? A into 1, that means just a, and it will become b into minus 1, means it is minus b, and in c and d it will become only remaining d and minus d. So here we will get, just we are putting x values in that equation. So here we are getting a, b, and d, and already we have the values of a and b. So here we can substitute the values of a and b. That means 1 is equal to, what is our a? So a is equal to 1 by 4. What is our b? So b is minus, so minus and minus will become plus 1 by 4, and then minus d. That means from here it is 1 by 2, and we are taking 1 by 2 left side. So it will become, from here we can say d is equal to minus 1 by 2. Minus 1 by 2. If you have confusion, this 1 by 4 plus 1 by 4 will become 1 by 2. And we are taking left side. So 1 minus 1 by 2 is 1 by 2. But since minus sign is there here, so this minus also will come. So d is equal to minus 1 by 2. Now we know A, B, and D, but still C we don't know. So for that, put any other value. So for that, we are putting, let us suppose D x is equal to 2. So if you are putting x equal to 2, this will become what? 1 will be as it is. A, A will be multiplied with, here it is 2 into 1, that means 3. And 2 square, 4 plus 1, that is 5. Right now, plus b. B will be multiplied with what? So 2 minus 1, so it is 1 and 5. Right? But with this c, here what we are getting, it will become 2c plus d, 2c plus d, right? And here it is going to become 2 minus 1, so 1, and 2 plus 1, 3. So we have these values. Now we are going to same time substitute. We will simplify and substitute the values of A, B, and C also. And then D, then we'll get the C. So here 1 is as it is, and this is 15 time of A. And A is what? So A is equal to, as we know, already we found out the values of A, it is equal to 1 by 4. So A is equal to 1 by 4 plus 5 time of the B. What is B? So B is minus 1 by 4. So here I am writing the values of this, plus here it is 3C, that means 3 into 2. So it is 6C. So here I am writing 6 time of this C, and 3D plus 3 into D. So D is what? D values is minus 1 by 2. So here I will write minus 1 by 2. Right now we can take the LCM on the LHS side, RHS side, sorry. So LCM I am taking 4. So it is 15, and this is minus 5, and here this will become plus 24C, and here it is minus 6, and this is equal to 1. So cross multiply, 4 will be equal to 15 minus 5, 10, 10 minus 6, 4. So it is 4 plus 24C. Right? Now from here what we can do? 4 and 4 will become 0. So 0 is equal to 24C. 0 is equal to 24C. That means from here we can say C is equal to, finally we are getting 0. C is equal to 0. So what is our final integrations? Here we will write the final integration. I is equal to, here I am writing I will be integration of first term, that is a by x minus 1. A we have 1 by 4. So 1 by 4 divided by x minus 1 dx plus b. B is what? So we have minus 1 by 4, and this is divided by x plus 1 and into dx plus cx into d. So c d only will be remaining, means minus 1 by 2, because c is 0. So here it is divided by x square plus 1, or 1 plus x square also we can say. This is the final form. Now we have to apply the formula directly, we can apply. So it will become, here it is actually 1 by 4 for the both the equation. 1 by 4 is common only, right? Means here I will write, next step will do that. So here for the first term log, it will become mod x minus 1. From here 1 by 4 and log mod x plus 1, right? And here minus 1 by 2 outside, and it is nothing but tan inverse x formula. It is direct formula. And here we can take the 1 by 4 common. So it will become log a minus log b, and apply the properties. It is 1 by 4. And properties of this, log a minus b will be equal to x minus 1 divided by x plus 1. And here minus 1 by 2 tan inverse x plus c. Okay, so this is the answer of the question number 15. Actually it was lengthy, right? So this is done. Now I'm going to move on the next slide, that is question number 16. So what is question number 16? Here we have given integrate 1 by x into x to the power n plus 1 into dx. How we can do that? Here we can see in the denominator we have x to the power n. What if their differentiation is present in the numerator? What we can do? Means what is the differentiation of x to the power n? So their differentiation will be n x to the power n minus 1 or not. Means here I am just telling you concentrate on this part, x to the power n. So differentiation of x to the power n is what? N x to the power n minus 1. So that's what I am going to do here. I am going to write I is equal to multiply and divide with the differentiation of x to the power n and only variable one. Means here multiply with x to the power n minus 1 and divide also with the x to the power n minus 1. And here already one x is there, so that we can apply the substitutions here. In this type of the questions, always we are applying this concept. We are thinking of this term. What is the differentiation of this? So x to the power n minus, for sure it will come. So we are writing here in the numerator and denominator. Now next step we are going to just simplify. So this our I will become integration of x to the power n minus 1, and here this will become x to the power n, because power will be added here, power is 1, right? And here we have x to the power n plus 1 and into dx. Next we can directly apply the substitution. So let x to the power n is equal to t. So what is the differentiation of this? This will become n x to the power n minus 1 into dx is equal to dt. Right? Means now our I will become, over here one more step I will write. What is that? X to the power n minus 1, x to the power n minus 1 into dx, 1 by n, 1 by n into dt, right? So finally we can write I is equal to 1 by n and integration dt divided by, what is x to the power n? This is t, and here also it is t plus 1, t plus 1. Now here we can apply the partial fraction, or shortcut also we can apply. Means I will write it as 1 by n. This can be written as t plus 1 and minus t, because it is just 1 only, right? So in the numerator we can replace the 1 with these values, and here it is divided by t and t plus 1 as it is. But in the next step what we can do here, here I am writing I can be written as 1 by n is outside as it is. Here we can take the t plus 1 and divide it by t into t plus 1 minus, here I am taking bracket, so minus t divided by t into t plus 1, right? And then into dt, right? So it will become 1 by n, integration of t plus 1 will get cancelled out. Here we will get 1 by t, and here 1 by t will get cancelled out, 1 by t plus 1 dt. So it will become 1 by n, and here integration of the first part is log t, and integration of the second part is log t plus 1. We should take mod also, log mod t, log mod t plus 1, and here plus we can apply the properties of the log. So log a minus log b will become log a by log b. Means here we can write log of mod t divided by t plus 1. All right, and here plus c. Now replace the values of the t. So what is our t here? Log t is equal to, we have x to the power n. So it will become x to the power n divided by x to the power n plus 1. And here plus c. So this is the answer, final answer of the question number 16. Right? So what is the next question? The question number is 17. So 1 second. 17 questions we have. Cos x divided by 1 minus sin x into 2 minus sin x. How we can do that? Here, actually it is directly not visible, like we can apply this partial fractions or not. First we have to substitute or relate this sin x, because differentiation of sin is present in the numerator. So we are going to assume this sin x, means let this sin x is equal to t. So what is the differentiation of the sin x? It will become cos x into dx, and this is equal to, we can write dt, right? Means now our I will become, I is equal to, here this can be written as dt, and this is divided by 1 minus t, because sine we have considered as t, and this is 1, this is, sorry, 2 minus t. Right, now here we can apply the any method to simplify this. Here I can write it as 1 minus t and 2 minus t is there. How we can write? So that, because in the numerator it is just 1, we can say here it is 1. So can we do the rearrangement here? Means 2 minus t, here we can write it as this 2 minus t, and then minus here 1 minus t. So it will be 1 only, and here it is divided by 1 minus t into 2 minus t, or otherwise we can apply the partial also. This is the shortcut we can do, or otherwise partial also if you apply we will get the same thing. Means here now we can take 2 divided by t, this 2 minus t, and divided by 1 minus t into 2 minus t here, and minus here 1 minus t divided by 1 minus t into 2 minus t, right here. Now what are the common terms here? We can cancel the common things. So as you can see here, this 2 minus t, 2 minus t, 1 minus t, 1 minus t, cancel. So what are the remaining terms here? We have now just integration of 1 by 1 minus t, and here minus 1 by 2 minus t, right? And then d, actually it is dt here, because everywhere actually it is dt, because we have converted it to dt. So it did dt. Now here we can directly apply the formula, so it will become, or before that we can do one more thing here. Let's take the minus sign common from this both, or let it be as it is. We'll take the minus in the denominator only. Means it will become here log of, or with the minus sign, here minus I'm taking outside because coefficient of the t is minus. So log 1 minus t, and here minus and minus will become plus log of mod 2 minus t, right, plus c. Now we can apply the properties of the log. It is log a, log b, and this is minus log a. So it will become log 2 minus t, and this is divided by 1 minus t. Order we need to change. Here it is, we are considering this is a and this is b. So a minus b, so it will become a by b and plus c, right? That means finally what we can write, so we can replace the t, means it will become log mod of t is equal to sine, so it will become log 2 minus sine x and divided by 1 minus sine x plus c. So this is the answer of the question number 17. Right, now we move to the next question, that is question number 18. Yes, here how we can do that. In the question number 18, you can see there are four factors, but all are non-factorizable, right? Means first we are going to reduce it by taking this x square as any other variable. Let us suppose I am taking this x square as t just for solving this. So let x square is equal to t. That means here we can write this expression as t plus 1 because I am replacing x square with the t, and this will become t plus 2. Alright. And here this will become t plus 3 and this will become t plus 4. Alright. Now we have to apply the partial fraction on this. But can we apply directly? No, because you can see here the power of the variable in both numerator and denominator are same. That means it is not a proper fraction. So first we have to multiply it and then divide it and convert in the proper fraction. So multiplication of the numerator will become t square plus 2 plus 1 3t and plus 2. If you multiply, we will get this thing. And multiplication of the denominator is t square plus 7t plus 3 into 4, that is 12. So now we are going to divide this t square plus 3t plus 2 by what? So by t square plus 7t and plus 12. By this we are going to divide. So in how many times we can divide it? This is plus sign here. So t square we want to cancel, so we have to just take 1. So it will become t square plus 7t plus 12. Means first here if you are changing the sign, this tt cancel. Here it will become minus. Here so it become minus. Means 3 minus 7. It become minus 4. Minus 4t and here it is minus 10. Right? So this we are getting, means now we can write our I. I am considering this given question as I. So I equal to, we can write in this form. That means quotient is 1 plus remainder is minus 4t minus 10 divided by divisor. So divisor is t square plus 70 plus 12, right? And here actually d, here we cannot actually write like this. We have to replace our t in this expression as, means without integrations only we can write, because we are not putting these values here. Once again, here this thing we will write just in the form of the divisor, and here we can write what, this I is equal to, or these values, this is this t plus 1 into t plus 2 by this thing we can write as 1, and then here plus minus 4t minus 10 and divided by what? So divided by t square plus 7t plus 12, right? Like this we can write. But here we can replace our t with the, we have to replace our t with the x, right? So what we can do now here, this is 1, if we are replacing, before that factorize it, already we know the factor of the denominator, means this is 1 plus minus will come common, so it will become plus, will become minus 4t plus 10, and this is divided by t plus 3, because already when we multiply then only we got this thing, so again we can write in the factor form, t plus 12, t plus, sorry, 2 t plus 4, t plus 4, this is 4. So now how we can simplify it? It is t plus 3 into t plus 4. So this part we need to simplify. Means from here, the second part, 1 anyway is simple, but from this we have to apply the partial fraction on this. For this part, 4t plus 10 by t plus 1. So here we are going to apply the partial fraction for that part only. Means I am writing this part separately. Which part? I am talking about this one. This much part we are going to take separately and simplify. So what is their simplifications here? This 4t plus 10 divided by what? So t plus 3. This is t plus 3 into t plus 4. Means this can be written as a divided by t plus 3 plus b divided by t plus 4. Right now we are going to take the LCM. So it will be 4t plus 10 is equal to a into t plus 4, and here b into t plus 3. So if we are putting here the values of t is equal to, here let's t is equal to minus 4. So it will become minus 4, means 4 into minus 4 is minus 16, plus here 10, and this is equal to 8 times will become 0, means b into minus 4 plus 3, it is minus 1. That means what we can say, it is minus 16 plus 10 minus 6, and here also minus minus will get cancelled, means b is equal to 6. We are getting b equal to 6. Now we have to find the a. So for that we will try to make the b 0. So for that we will take t is equal to minus 3. So if you are taking t equal to minus 3, then our equation will become 4 into minus 3, that means minus 12. Minus 12 plus 10, and this is equal to a into minus 3. So a into 1. So it is just 1 and b is 0. That means from here directly we can say a is nothing but this is equal to a is equal to minus 2. So now we have the values of a and b. So we can write this equation. Let us suppose this is our first equation. So this will be now 1 minus and 4. Actually, no, not this one. Here in the previous one, we can write this one is the second equation. So in the second one, from equation second, we are going to from equation second. This will become a, that means minus 2. So this part only we have this a by t plus 3 and b by t plus 4. So now we can directly substitute the values and we can replace t with the x square, means finally what we can say, our integrations will become now integration I is equal to 1, and here we are going to solve this part separately. This is curly bracket. Let me take the curly bracket proper. Here I want to take curly bracket because two bracket we have to use now. So second, this term I am going to write 1 minus this, 1 minus this one term. So a means minus 2 divided by t is equal to what? So t is equal to x square. So x square plus 3, right? And then plus b means 6. So 6 divided by x square plus 4. This is the I. Now we have to little bit more simplify. So what we can do, just we can write integration for all the terms separately. It will become 1 into dx, and here minus minus plus, so 2 outside, and we can write it as 1 upon x square, and this is root 3 whole square. 3 can be written as root 3 whole square into dx, right? Plus here 6 outside, and this can be written as x square plus 2 square into dx. Now we can write our answer directly. So here answer will be this part will give us x, and from here 2, and this is tan inverse 1 by a tan inverse x by a. That means 1 by a. What is a here? So a is root 3. So root 3 tan inverse x by root 3. Tan inverse x by root 3 here plus 6. So tan inverse and plus is 1 by a is 2. So it is this, and tan inverse x divided by 2 plus c. So this is the final answer. Just here we can do one simplification. What is that? This 6 divided by 2, it will become 3. So here the coefficient will be 3. So this is the question number 18, right? Now we'll move to the next question, question number 19. So what we can do here, here it is simple actually. Just we have to see that x square terms is given in the denominator. So if you are taking the x square is equal to t, so that differentiation is already present in the numerator. So let this x square is equal to t. Here we have x plus 1 and x plus 2, I think. It is missing. I think it will be 2 or 3, I don't know. But we are considering it as 2. So it will become x square. That means differentiation of this will become 2x into dx. And this will become equal to dt. Means now we can write our integration as dt divided by t plus 1 into t plus 2. Right? Means here finally it will become 1 by, where, or before that also I am just taking the LCM, then I will write this step. Means we can rewrite this as, here 1 should come, so 1 should come, that means t plus 2 minus t plus 1. Alright, and this is divided by t plus 1 into t plus 2 into dt. That means integration of t plus 2, if you divide separately, so we'll get cancel out. We will have here only 1 by t plus 1. T plus 1 into, and here minus t plus 1 will get cancelled out. Here we will have only t plus 2 dt. So it will become log of mod t plus 1 minus log of mod t plus 2, and here plus c. That means we can apply the log property. It will become log t plus 1 divided by t plus 2 plus c, and then finally here we can replace our t with x, so it will become log mod x square plus 1 divided by x square plus 2 and plus c. This is the question number 19. Alright, now what is the next question? So 20 question, here we have 1 upon x into x to the power 4 minus 1. It is again simple. Just we have to think about the differentiation of x to the power 4. So 4x to the power 3 will come. That means here let this is equal to I. So multiply and divide with x cube. So multiplying with x cube here, if you multiply with x cube, this will become x to the power 4, and here already we have x to the power 4 minus 1 and dx. So now let x to the power 4 is equal to any other variable t. So differentiation will become 4x cube dx is equal to dt. That means x cube dx is equal to 1 by 4 dt. Means now our I will become equal to integration of 1 by 4. I am writing outside only, integration of 1 upon x to the power 4 is t, and this is t minus 1, and here dt. Means we can now rearrange it. Means where here I can write t and minus of t minus 1, because it is going to become 1 only, and here it is t into t minus 1, t into t minus 1 and dt. That means finally this is nothing but here if you divide separately, t will get cancelled. We will have only t minus 1, and here t minus 1 will get cancelled out. So we will have only 1 by t like this into dt. So here what we will get, 1 by 4 is outside and applying the properties of the law same time. So here t minus 1 and here t plus c. That means now we have to just replace the t with the x term. So t is equal to x to the power 4 minus 1 divided by x to the power 4. And this is plus c. So this is the answer of the question number 20. Now we'll move to the next question, that is 21. Here what we can do, we have given e to the power x minus 1. Okay, so how we can simplify this part? Let us suppose here we are taking e to the power x is equal to t. Then what will be the answer? Means here for this type of the questions, I think we need to directly take e to the power x is equal to t. Let e to the power x is equal to t. That means their differentiation will be e to the power x into dx is equal to dt. But we have only dx in the numerator. That means this can be written as 1 by e to the power x into dt. Means this I will become equal to 1 by e to the power x into dt, and this is divided by what? So this is divided by, because we have considered this is t, so t minus 1. Means now as we know that e to the power x is equal to t, so again we can replace e to the power t with x with t, and here it is t minus 1, right, into dt. So now it is now simple. What we have to do here, we can write it as t and then minus of t minus 1, like in previous questions we did, and here it is t and here it is t minus 1 dt, right? So finally we can write I is equal to what? Here I equal to, we can write t will get cancelled. So the first term we can write 1 by t minus 1 into dt. I am writing separately, and minus here t minus 1 will get cancelled out, 1 by t into dt. Means here this will give log of mod t minus 1, and applying the properties of this, that answer will also come here, log t and plus c. Now we know that log of t means what? T means e to the power x, so e to the power x minus 1 divided by e to the power x, and here plus c. So this is the answer, final answer of the question number 21. Right, now we have two more questions, that is question number 22 and 23. So here what we can do, here directly we can apply the partial fraction. That means this x by this x minus 1 into x minus 2 can be written as a upon x minus 1 plus b upon x minus 2. That means this, after taking the LCM and cancellation to the denominator, it will become a into x minus 2 plus b into x minus 1. Alright. Now to find the value of a, b, put x is equal to 2 in this above equation. That means it will become 2 equal to b. So b equal to, we are getting 2. Now put x equal to 1. That means 1 is equal to a into minus 1. So a equal to, we are getting minus 1. That means now finally we can write our final answer. What will be the final answer? I is equal to integration of a, that means minus 1 divided by x minus 1 into dx plus b. B is equal to 2. So 2, 1 by x minus 2 into dx. And here it becomes minus 1 log mod x minus 1 plus 2 times of the log x minus 2 plus c. And this is here our final answer. Or we can apply the properties here also. So if you are applying the properties, because it is objective questions, options we need to match. So what we can do here, this minus will come to the top, means it will become 1 by mod x minus 1, and here it will become log x minus 2 whole square and plus c. Now this is in multiplication, so we can write it as addition. Log, both are in addition, so this will multiply. It will become x plus 2 whole square, and this will be divided by x minus 1. Right? And here mod, we are taking all the values between mod and plus c. So this is the answer. You can match the option. Right now, here too we can apply directly the partial fraction, means we can write it as 1 by x into x square plus 1 as what? A divided by x plus, since it is non-factorizable, so bx plus c divided by x square plus 1. Right now, taking the LCM, so it will become a into x square plus 1 plus b into, sorry, bx, bx into c, bx plus c, and this is all multiplied with x. That means 1 is equal to, we can say here we are getting a x square plus a, and from here we are getting bx square plus bx square plus cx. That means what are the like terms here? So taking constant common, a plus b and x square is common, right? And constant term is here one cx and constant is a. That means constant we can directly equate because it is given constant a is equal to 1. A is equal to 1 and a plus b, because there is no x square term in the LHS, so this is equal to 0. So a equal to 1 plus b is equal to 0. That means from here b equal to minus 1. Well, now we need to find out c. So c also is equal to 0 because there is no x terms. So it will become 0. Right. So finally, what we are getting, we can write our answer is I is equal to integration of a means 1 by x plus plus integration of bx, b is minus 1, so minus x divided by x square plus 1, because c is 0, x square plus 1 into dx. So for this actually we need to apply the substitutions again. So let this x square plus 1 is equal to t. That means their differentiation will be 2x into dx and this is equal to dt. But we want the values of x into dx. So for that we have to divide this 2. That means this part here I'm leaving the minus sign and taking only this positive part. So 1 by 2 and this is dt and t means for this it will become log 1 by 2 is outside log mod t plus c. Now 1 by 2, what is our t? So as we know that t is equal to x square plus 1 plus c. So finally our answer I will be equal to log of mod x and minus 1 by 2 log of mod x square plus 1 plus c. So this is the final answer, right? And last question of the exercise 7.5. So we have done with this exercise. Thank you.